Okay, guys, we're going to go as quickly as we can through these problems for your final exam review for college trig. First one, convert the angle to decimal degrees and round to the nearest hundredth of a degree. Okay, so this is where you have to remember that each minute there, remember that's a 60th, and quite honestly, when you're doing the seconds, it's a 60th of a 60th, which remember is 3600. And you're just going to sum those things up. So you're going to type 262 plus 7 divided by 60 plus 45 divided by 3600. Okay, and then we've got to make sure that we take it as far as they said. They said 100 of a degree, so I've got 0.129, which means we round to 0.13. Okay. Then we're going to go the other direction, convert the angle to degrees, minutes, and seconds. So the integer part is going to be the same. We're working with the decimals, so type in your 0.69. You're going to do the opposite of what we did before, and you're going to multiply by 60. And I got 41.4. Okay, so that's what I've got. So 41 becomes the minute part. We're going to keep the 0.4. The 0.4 needs to be multiplied by 60 again, and that gives me 24 seconds. So that should be our answer right there. Okay. Next one, draw the given angle in standard position. Draw an arrow representing the correct amount of rotation. Okay, so 115 degrees, that is over 90. So we're going to need to go, somewhere around in here. The arrow is that rotation that they're talking about. Find the measure of two other angles, one positive, one negative, that are coterminal with a given angle. So remember, coterminal means you basically spin a circle. So you need to add 360, that gives you the positive, subtract 360, that's going to give you the negative. So 115 plus 360, if you add 360, we're going to come up with 475. If we do 115 minus 360, it's just a matter of typing it in, and you get a negative 245. So these are the two answers that we need. And you're going to need that picture as well. Okay, solve the problem. A wheel makes 372 revolutions per minute. Now that might be nice to actually make a note of that. So we've got 372 revolutions in 1 minute. Okay, so how many revolutions does it make per second? So basically you're converting from minutes to seconds. Keep in mind, we're wanting to change this denominator. So 1 minute is equal to 60 seconds. And, I mean, you can think through this different ways. I just happen to like the factor label method. I've got my minutes where they will cancel out, so that gives me 372 in the top and 60 in the bottom, and that is revolutions over seconds. It's just a matter of can you type it in and reduce. 372 divided by 60 is 6.2 revolutions per second. Okay? All right, suppose that theta is in standard position and the given point is on the terminal side of theta. Give the exact value of the indicated trig function for theta. Okay, basically, let's plot our point. Negative 3, 1, 2, 3, and up 2. Let's complete that as a triangle, which means it is, don't forget the negative, because you went left, you got to put the negative. Okay, but we want cosine of this picture. Remember, cosine is adjacent over hypotenuse, so we need hypotenuse. That's not one of the traditional triangles, so we've got to do 2 squared plus 3 squared. There's no need to do negatives because even if you put the negative, when you square it out, it's going to be gone. Okay, so we're going to have 4 plus 9 equals x squared, so x is square root of 13. Yes, I'm going to skip some stuff because y'all are college algebra kids, college trig kids, and you should be able to do this. Cosine is adjacent over hypotenuse, so that's going to be negative 3 over square root of 13. You must rationalize and make it negative 3 square root of 13 over 13. Can't reduce, so you're done. Okay, evaluate the expression. And so it looks like we have values from the unit circle. So if we draw a unit circle and label it, we should be good. So we need 1, 0, 0, 1, and please make sure you're getting your ordered pairs done correctly and not doing them backwards. Okay, remember cosine is the first value, sine is the second value. If you want tangent, tangent is going to be sine over cosine, and then you can do the reciprocals if you need them. Looks like we're going to need it. I would structure this first because you got a bunch of squares going on. We have 8, and then it's going to be tangent 360 squared minus 2, and then we're going to have a value squared, and then we're going to have 9, and then we're going to have a value squared. So I'm just translating all these squares down there. So once I evaluate tangent 360, I can just place those values in there. So 360 degrees is right down here. Tangent is going to be sine over cosine, so back number over front number is 0 over 1, which is 0. Okay, sine of 180. 180 is over here on the left. Sine is the back number, which is 0. Okay, cosecant, if you remember, that is the reciprocal of sine. So we're going to find sine, we're going to turn it upside down. 270 is down here on the south portion. Sine happens to be the back number, which is -1, but when you do the reciprocal of -1, you get -1. So the zeros work lovely, and they're going to cancel out. These just go away, and all we're left with is this little portion here, which is 9 times 1, with 9. You know, it works out very well. Okay, find the value of the variable in the equation. Well, first thing you have to do is figure out what in the world is going on. There's got to be a relationship that you can work with. We have secant on the left, and we have 1 over cosine on the right. Hopefully it dawns on you that secant and cosine, they're reciprocals, and this is written as reciprocals, which means my angles must be equivalent. So I'm going to take the angle here and set it equal to the angle over here, and just solve the basic algebraic equation. There's nothing weird about this. It is just normal. I'm going to show the steps because some of y'all have little blonde moments, and we just want to make sure we're getting all of it right. Okay, but it's just traditional algebra, guys. That's all it is. Nothing new, nothing spooky. Divide by 3, it's 13. Okay. Let's see here if I can get the button to go. Determine the sines of the given trig functions of an angle in standard position with a given measure. Okay, well, first of all, 489 is not a value I'm used to dealing with. I need to get something coterminal that is in that normal range of 0 to 360. So we're talking about our initial circle. So let's take 489 and take 360 off of it. When we do that, what we're really talking about is cosine of 129 and tangent of 129. Okay, now 129, remember we got 90 here, 129 is in second quadrant. All students take calculus. These are the values that are positive. Okay, and that's what it's asking us about, is what are the sines. So if sine, S-I-N-E, and its reciprocal are the only things that are positive in the second quadrant, that means both cosine and tangent will be negative in quadrant 2. And that's all it's asking for. Identify the quadrant for the angle theta satisfying the following conditions. Okay, once again, same idea of your all students take calculus. This is where everybody's positive. Now, this is kind of like a distraction. Think about it in terms of its reciprocal. Tangent is also less than 0, which means negative. And this is cosine is positive. Now, it doesn't matter which one you start with, but just pick one and roll with it. Most people like to think with positives first. So where's cosine positive? Everybody's positive in the first. Cosine's positive in the fourth. Now, whittle it down some more. Which one of those two that I just circled has the value where tangent is negative? Well, since everybody's positive up here, it's got to be in fourth quadrant. That's the winner. All right, let's keep going. Decide whether the statement is possible or impossible. So this has to do with your ranges. Helps a lot if you think about your graphs. If you will remember that sine and cosine, those are the two that, you know, if you just do your traditional graphs of your basic functions, your basic paragraphs, they sit there and they bounce in between -1 and 1, okay? And secant and cosecant, since they're the reciprocals, they're the ones that go from -infinity to -1 and from 1 to infinity. So whenever you think about this, secant can't be in this zone right here, okay? So this is too small of a value. Wait, I said that. it just doesn't work because I guess it's not small enough. It's got to be less than -1 or greater than +1. So this is impossible. Okay, you just can't work it. Okay, use the fundamental identities to find the value of the trigonometric function. So find sine if you know that cosine is 2/5 and you know it's in quadrant 4. So let's take our clues and draw the graph. Quadrant 4, let's drop a triangle in there. We know that cosine is 2/5. So that means adjacent is 2, hypotenuse is 5. This is not a special condition. So we've got to come over here and do Pythagorean theorem to find the missing side. So 2 squared plus I don't know squared equals 5 squared. So 4 plus x squared equals 25. X squared equals 21. Take the square root. We got the square root of 21. There's nothing you can do with that. It is going down, so please do not forget to put the negative on it. Direction is important. So once you've got your picture labeled, all you have to do is look at the picture and determine sine. So sine is defined as opposite over hypotenuse. So negative square root of 21 over your hypotenuse, which is 5. Okay, evaluate the function requested. Write your answer as a fraction in the lowest terms. So find tangent of A. So they're telling you where you need to view from. We're coming down here at A. Tangent is opposite over adjacent. So opposite is 2. Adjacent is square root of 6. Yes, you're going to have to work for it. So we're going to have to rationalize. Yeah, if you can rationalize in your head, that's lovely. Please don't leave this. You do need to clean it up and reduce. But remember, outsides play with outsides and insides play with insides. So only the 2 and the 6 in the denominator can reduce. And 2 goes into 2 one time, 2 goes into 6 3 times. So we have square root of 6 in the top and a 3 in the bottom. You cannot reduce because these two don't play together. You have an inside and an outside. You're done. Okay. Write in terms of the cofunction of a complementary angle. Please remember that complement means that we add to 90. Okay, so remember, and it's cofunctions. So that they've got both the terms in here that are supposed to clue you into what to do. The cofunction of tangent is cotangent. And then complement means, let's take this and we're going to do 90 minus 76. So 90 minus 76, I do believe that's 14, but let's just type it in, just make sure I don't make a crazy mistake. And that is it, cotangent of 14. We might have time to squeeze another one in. Assume that all angles are acute, and we're trying to look for the solution. When you look at this and you start thinking about the relationship between sine and cosine, the only relationship they have is cofunctions, which is what we just talked about. Cofunctions of complementary angles are equal. So that means if these things are set equal, our angles must be complements. Translation, these angles must add up to 90. So we have 2 beta plus 10 equals, plus 3 beta minus 25 equals 90. Okay, and then it's just basic algebra. Put your like terms together. We have 5 beta, and that's going to be minus 15 equals 90. If you move your 15 over, I do believe that's going to be 105. And if you divide that out, how many nickels are in $1.05? That would be 21. Okay, so that takes us through number 14. We'll pick it up with number 15 in the next video.